This is a presentation on solving simple radical equations by Mathematically Marcia. Okay, before we look at how to solve an equation, let's talk about inverse operations. If I have a positive number, or if I'm adding a number, the inverse of that is subtraction because, or it's also known as an opposite with addition, because you're trying to eliminate it and make it zero. So we subtract. So the inverse of addition is subtraction. You get x equals 2. Or the inverse of subtraction, or the opposite of a negative, is a positive. So you add. And those are the inverse operations. For multiplication or division, or multiplication and division are inverse operations, because when you divide something by itself or multiply by a reciprocal, you get 1. And so those cancel, leaving you with 1x equals 4. Or if it's being divided, you can multiply by the reciprocal of 1/3, which is 3 over 1, or 3, to get 1, and x equals 36. Now, let's look at the inverse of a radical. Keep in mind about how we solve radicals when we are simplifying radicals. We look for pairs that we can pull out. So if I want to pull that x out of a radical, I need another x. So if I multiply it by itself, that would give me x times x, which is a pair, and cancels it and lets it come out. Or another way to look at it, remember we talked about changing it to, in another video, about changing it to an fractional exponent or rational exponent. Remember there is an imaginary 2 here, so that would be x, 2 is the numerator, 2 is the denominator. That reduces to 1, or just x. So the square and the square root are inverse operations, or they cancel each other out, bringing you down to x with the exponent of 1, which is what we want when we're trying to solve the equation. All right, so let's apply this to an equation. As we just discussed, the inverse operation of a square root is a square. That's how I cancel a square root. And just like solving any other kind of equation, whatever I do to the left side, I have to do to the right side. So if I square the left, I have to square the right. So square root of x squared, the square root and the squared cancel. That becomes x, and then 3 squared would be 9. So x equals 9. And we can check this by plugging x in. Square root of 9 should equal 3, and the square root of 9 does equal 3. So our answer is correct. All right, anytime we have a radical equation where the radical equals a negative, our answer is no solution, because it cannot equal a negative. So we are finished with that one. Okay, it looks like a radical equals a negative again, but it actually doesn't yet, because a radical is not by itself. So before we're ready to get to that point, we need to get the radical term alone. And we do the other inverse operations to get there. We see that we have a minus 8 over here with the x, so we do the inverse of minus, or the opposite of a negative, which is plus 8. And whatever we do to one side, we do to the other. So that will cancel that. We have our square root of x here. And negative 2 plus 8 is 6. Now we see it's positive. Now that the radical is by itself, we can do the inverse of the square root, which is to square. And so x equals 36. And let's check it. Go back to the beginning to check it, plug it in. Square root of 36 minus 8 should equal negative 2. So square root of 36 is 6 minus 8. And then 6 minus 8 is, in fact, negative 2. So that does check. This is our correct answer. All right, let's again do inverse operations. Inverse of minus 4, or opposite of negative 4, is plus 4. So 2 radical x equals 12. Now at this point, you've got the radical term by itself, so you could go ahead and square. However, if you can, I would go ahead and divide and get rid of this coefficient also. So square root of x equals 6. Now we can square both sides. So we get x equals 36 again. And let's check it. So 2 times the square root of 36 minus 4 should equal 8. So 2 times 6 minus 4, which is 12, minus 4, which is 8. So our answer checks, it is correct. Okay, this one looks a little bit different. We do have the radical by itself, so we are ready to square both sides. Remember, the square and the square root cancel. So whatever your radicand is what we have left. So we have x minus 4, and then 2 squared is 4. Now we need to do inverse operation to finish solving. So the inverse of minus 4, or the opposite of negative 4, is plus 4. And we get x equals 8. Now let's check it. 8, square root of 8 minus 4 should equal 2. Square root of 4 should equal 2. So 2 equals 2. So our answer is correct. Okay, before we can get rid of the radical, we have to get the radical by itself. So let's start with this plus 10 over here and subtract 10. So 3 square root of x minus 4 equals negative 6. Divide by 3. Square root of x minus 4 equals negative 2. Remember, a radical cannot equal a negative, so it is no solution. Okay, when you have a radical on both sides, we still do the same thing. We can eliminate the radical by squaring it. So we just take each one and we square it. So x minus 3 equals 2x minus 6. Okay, so now we need to get the variables on the same side. You could move either one, x or the 2x, by doing the opposite. I'm going to move the smaller one. So we'll subtract x from each side. Negative 3 equals x minus 6. Now we need to add 6 to both sides. So 3 equals x. All right, now let's check it. Square root of 3 minus 3 should equal square root of 2 times 3 minus 6. And over here, 3 minus 3 is 0. 2 times 3 minus 6 is also 0. Square root of 0 is 0. So that does indeed check. X equals 3. Okay, another one that's similar. We have a radical equal to a radical. So we'll again square both sides. So we get 3x minus 4 equals x minus 10. And then let's get the variables together. I like to do the opposite of the smaller one so that I don't have a negative variable. It gives you 2x minus 4 equals negative 10. Now we'll do inverse operations. So add 4 to each side. We do have a negative here now, but that's okay because we don't have a radical anymore. Your answer can be negative. You just can't have a radical equal to a negative. Okay, now let's check our answer. We got x equals negative 3. So square root of 3 times negative 3 minus 4 should equal square root of negative 3 minus 10. So negative 3 times negative 3 is negative 9 minus 4, which is negative 13. Get negative 13 over here. Now that is not okay. You can't have a negative inside of a radical. So this solution does not work. And we actually have no solution left. So it is no solution. And the x equals negative 3 is what's called an extraneous solution. We solved it correctly and got that answer correctly, but then when we plugged it in, it didn't actually work. So we have to throw it out. And we didn't have any other solutions left, so that would be why it was no solution. Okay, here's one more where we've got a radical equal to a radical. So same thing, just square both sides, and that will cancel both radicals. So we have 3x plus 10 equals x plus 6. Okay, again, let's get the variables together. So I'll subtract the smaller one. 2x plus 10 equals 6. Now do inverse operations to finish solving. Opposite of plus 10 is minus. So 2x equals negative 4. Divide by 2. X equals negative 2. We have a negative answer again, but that's okay. Remember, it's not a radical equal to a negative. We do need to check it, though, and make sure the answer does work, and that we solved it correctly, and that it's not extraneous. So we have the square root of 3 times negative 2 plus 10 should be equal to the square root of negative 2 plus 6. 3 times negative 2 is negative 6, plus 10 is 4. And negative 2 plus 6 is also 4. So we have square root of 4 equals square root of 4, which is 2 equals 2. So this time our negative number is correct. And it does solve or satisfy the equation. If you have any questions, need clarification, or request for future videos, please share in the comment section below. Also, if you thought this was helpful, please like it and subscribe to my channel so you can see some more videos like this. And thank you for watching.